We're going to take a look at variation and what that means mathematically. We're going to start by looking at some real-life examples. So, first example is the amount of money a person makes and the number of hours worked. So would that be direct or would that be inverse? Well, let's take a moment and think it through. If they work more hours, so the number of hours increases, what happens to the money they make? Well, that should increase too. So if both items are increasing, that means that these two vary directly. Let's take a look at the second example, the amount of Moxil that is recommended for children of various weights. A Moxil was the med on our quiz. It was based on the child's weight, so when the child weighed more, they needed to take more Amoxil. And whenever we're dealing with a weight-based med, we end up multiplying. For example, heparin, if it's 18 units per kilogram, we multiply by the weight, and we know multiplication goes with direct variation. We also know that when both items increase together, they are directly related. Next, we have the state income tax paid and our gross income. So if we make more money, what happens to our taxes? Well, unfortunately, we have to pay more. So both are increasing. That means there is a direct variation relationship. Number 4, your average speed and the travel time from Lancaster to Philly. Well, if your speed increases, what happens to your travel time? That should decrease. So as one goes up, the other goes down. That means that these have an inverse variation relationship. Fifth one, the length of time that you are taking a statin to the amount of cholesterol in your arteries. So as time increases, hopefully the cholesterol decreases because statins are to remove cholesterol. So the arrows are going opposite directions. This is an inverse variation relationship. Now, in each relationship, there also has to be a constant K. So if we go back up here and look at number 1, what is constant is the dollars per hour that they are paid. So they might make $10 an hour. That's constant. And we use that constant to calculate the money they make. When we look at the medication, perhaps it is ordered for 20 milligrams per kilogram. And so that piece that would be on the label is constant, always 20 milligrams per kilogram. When we look at our income tax, our tax rate is constant. So we can go to our PA State website, look up our tax rate, and figure out our income tax. When we're talking about speed and travel time, we have in here from Lancaster to Philly. So our distance is our constant. Now, when we talk about the scenario with the statin and the amount of cholesterol, there would be many factors that weigh into determining the constant. So how fast your particular body produces cholesterol, your history, your exercise, your diet, all of them come into play. So I'm not able to put my finger on exactly what that constant is in real life. So let's take this concept of how things increase or decrease and how they're related to look at some examples. I have on this side key relationships pertaining to blood circulation. They come from your A&P book. So as I look to model each relationship with an equation, first thing I have to do is define variables. So here is the subject of my sentence. That is my first variable. So I'm going to let F equal flow. Here is my verb. In math, that verb is the equal sign. Here's the word proportional, which is one of our key words for directly, and it's proportional to the pressure gradient. So that is my other variable, and I'm going to use P equals the pressure gradient. When I go to write an equation, I follow the English. So the subject of the sentence is flow, so I put that first in my equation. The verb is next. It's circled there. It's is. The verb is the equal sign. In variation, the equals is always followed with K, and you can see that in your pre-lecture notes. Every time K follows the equals. Since this is proportional, and that is a key word for direct, I am going to multiply this times the pressure gradient. And so that is my formula for that relationship. So we look at number 2. Flow is the subject. Is the verb. My relationship is inversely, and it's to resistance. So I need a new variable, and I'm going to use R is equal to resistance. So I write my equation. Flow is the subject, so F. Is my verb, that's equals. Next is K every single time. Now it's inversely. Our pre-lecture notes tell us that that's division, so I'm going to divide by resistance. The last one. Flow is my subject. Is the verb. Directly proportional to the pressure gradient, that's another variable. And inversely proportional to the resistance, that's my other variable. So I have flow, subject, equals verb, always followed by K. It is directly proportional, so multiply times pressure. And inversely, I don't add a new K, I just add a new relationship, so I put the division in for the inverse, and I put the R. And so I've modeled this complex relationship between our blood flow, our blood pressure, and the resistance, things like cholesterol that would want to stop our blood from flowing.